Hello, Mr. Sunderland's interactive math students. This is Mr. Sunderland. I hope you guys are doing okay. We only have a little less than 4 weeks to go here, so let's put our heads down and finish strong. And before you know it, you guys will officially be on summer vacation. Hopefully, we will be able to actually do things again by then. So, what we are going to work on this week is I want to review some of the factoring or one of the specific factoring techniques I showed you last week, and I want to show you how you can use the quadratic formula to solve quadratic equations. So let's do a little bit of review from last week. When you are ready, go ahead and pause the recording and do your best to solve each of these quadratics by factoring. Okay, so in this first one on the left, I see that I've got it equal to 48, and in order for us to solve a quadratic, we typically want to make one side equal to 0. You don't always have to do that with some other methods, but for our purposes here with factoring, we certainly do. So I subtract 48 from both sides, and I've got a quadratic that I can factor. Now, because this is one where a might have an a value of 1, meaning just 1x squared, we can go ahead and put negative 48 in the top of our diamond, negative 2 in the bottom, the last term in the middle term, and figure out what multiplies to negative 48 and adds up to negative 2. And that would be negative 8 and positive 6. Because this is a 1x squared type of problem, those go right into our binomials. And I write that as x minus 8 times x plus 6 equals 0. And then that last step is the easiest one. I just set each of those equal to 0 and solve for x, and we get x equals positive 8, and we get x equals negative 6. Okay? Yeah, I'll even add in here that I skipped a step on you. We have x minus 8 equals 0, so you add 8 to both sides, and x plus 6 equals 0, in which case you subtract 6 from both sides. That's where I get that sign changing from negative to positive and from positive to negative. Let's go ahead and solve this other one. Okay, I've got a trinomial, 3x squared plus 7x minus 20 equals 0. So the method I was trying to show you last week was start with your diamond. Because this is an a value greater than 1, I need to think of multiplying a times c to get negative 60. So I need factors of negative 60 that add up to positive 7. And those are negative 12 and, negative 5 and positive 12. So once I've found those two factors, the thing I was trying to show you last week was that you can take whatever this a value is, which is 3, put it with an x on top of two fractions. So I have 3x and 3x as my numerators. The two factors we found here, negative 5 and positive 12. If you can simplify the fraction, you have to in order to factor it right. And this one on the right actually gives me 1x over 4. The one on the left doesn't simplify at all. Great, it makes it less work for us. And I just get 3x minus 5 times x plus 4 equals 0. Now that we have it factored, we're really happy because it's an easy problem from here. I just set each binomial equal to 0, solve each of these equations. Here I'm going to add 5 and divide by 3, so I get x equals 5 over 3. Move this over. And then here I subtract 4 from each side, and I get x equals negative 4. Quadratic formula. Here it is. I think I've shown it to you briefly before. And let's practice using it. So I'm going to actually use the same quadratic that we solved by factoring. But this time we're going to use the quadratic formula instead. Here's our quadratic formula. And let's write down specifically what a, b, and c are that we're going to plug into this formula. A is whatever term is with your x squared, so that's a 3. B is whatever term is with the x, so that's 7. And then c is your last term, keep in mind, because it's minus 20, my c is going to be a negative 20. I plug all that in here, and I'm going to go from this nasty expression here. If I follow PEMDAS really closely, it's going to clean up nicely into that. How I got 289 was 7 squared is 49. And then over here, we're going to multiply negative 4, 3, and negative 20. Well, that gives us positive 240. So really in the square root, you had 49 plus 240, and that's where my 289 comes from. 2 times 3 gave me 6. And because 289 is a perfect square, it's 17, we can set up two equations. The plus or minus means we actually have to do the problem twice from here. We have to do negative 7 plus 17. We have to do negative 7 minus 17. Okay? In solving those, I add 17, I get 10 over 6, which simplifies to 5 over 3. This one will give us negative 24 over 6, which is the same thing as just negative 4. One more here, and this one is actually going to give us a nastier answer, but it's going to actually mean less work as well. Check it out. We've got our quadratic formula. Let's write down our a, b, and c values so we can make sure to put the right things in. I'm going to do a positive 2 for a, negative 3 for b, negative 17 for c. Plug all that into the equation. Now the most common mistake here that students will sometimes make is they will not put the negative 3 for b in parentheses, so that when they square it on their calculator, they actually get negative 9. But technically, negative 3 times negative 3 is positive 9. So when we clean up that whole square root there, I get 9 plus 136, and that gives us 145. Now here's the good news. 145 is not a perfect square. It's also a radical that I can't simplify. So I'm done. Those are my two answers. 3 plus root 145 over 4 and 3 minus square root of 145 over 4. Sometimes we just write our answer like that and leave it that way. Depends on your teacher. Everyone's kind of got their own way of writing that. So I've got a worksheet for you on the website. The worksheet has a key at the end. If you want to go over there and practice a few of the quadratic formula and then check your answers, that'll be a great place to do it. Hang in there, my friends. We will hopefully see each other quite soon. Okay? Take care.